Good evening, sir.
Good evening, sir. Sir, am I audible? Shall I start? Thank you so much, sir. So, a very good evening, everyone. I hope I'm audible.
Yes, ma'am. Good evening.
Yes,
Yes,
good.
ma'am. Yes, ma'am.
Yeah, good evening, everyone. So, I hope everyone is ready and we can start with the session today. Yes,
We are ready.
yes, fine. So, I think yesterday, not yesterday, day before yesterday, we have discussed about the t-test, right? Today is the day where I'm going to talk about the next parametric test, which is ANOVA, right? So anyone is having any idea what is ANOVA?
Well, ANOVA is a statistical method used to compare the means of three or more groups to determine if there are significant differences between them.
Very good. Thank you so much, Neeraj sir. Neeraj sir has said very correctly when we talk about ANOVA. ANOVA is a statistical test which can help us to compare the means of three or more groups, right? Fine. So I think sir is having idea and I'm expecting other is also having the idea. So I'm going to share my screen first. And I want in confirmation from your side whether the screen is visible or not. Please give me a confirmation. Is it visible?
Yes, ma'am.
Yeah. So I'll start with concept of ANOVA, which stands for analysis of variance, right? So the variance of mean we are comparing here as it is a parametric test. So parametric test meaning is that we will be bothering about the normal distribution of the data first thing, right? That is why it is a parametric test. If generally the assumptions of ANOVA not met by the data, in that case what we do, we generally go for the non-parametric test category and we are applying Kruskal-Wallis test. So the substitute of the ANOVA in the non-parametric test category is Kruskal-Wallis test, right? Further, the purpose, I think sir has already said that we compare the mean of PV in the three or more groups of IB, right? So I think this is already we have seen in case of t-test also, right? When I talked about t-test, I said this thing t-test is also we are using to compare them. So the difference in independent samples t-test and the ANOVA is that independent samples t-test can compare only the mean of the two groups, not more than two groups, right? Whereas ANOVA can compare the mean of more than two groups, right? So whenever you want to compare more than two groups simultaneously, you will go for the ANOVA, whereas the t-test can only compare at a time two groups for mean, right? So the difference is quite clear, I hope. Clear, everyone? I hope it's clear. Friends, audible? Yeah.
Clear.
Yeah. So this is what about the difference further. Talking about the variable requirement. So variable requirement is or will be almost same as the independent samples t-test. That is, we need to have one DV, which is numeric or continuous, right? And one IB, which is categorical with three or more groups, right? Generally, this is the variable requirement in case of ANOVA. So we want to compare the variance in the mean of the numeric variable in more than 3 groups. That is why we are using ANOVA. Now further, if you have heard about the types of variety in the ANOVA, so there are 2 types of ANOVA. First one is one-way ANOVA, and the second one is two-way ANOVA. So one-way ANOVA meaning is that your table will be one way. That means you will compare the mean of your numeric variable in the groups of one categorical variable only, right? So that means it will be the same requirement which I have written here. That means we will be having one DB and one IB. DB should be numeric, IB should be categorical with 3 or more groups, right? So the purpose is generally you are making your hypothesis like there is no significant difference in the mean of DB in the various groups of IB. This is generally your null hypothesis. Then if I talk about the next test, which is the two-way ANOVA, here again there is a bifurcation. Bifurcation is generally this bifurcation I'm firstly writing. Maybe you have heard about, that is with replication case and without replication case. Anyone who has heard about with and without replication previously, priorly? Yes?
No, ma'am, no.
Okay, fine. So if not heard, and if you are new to this concept, so this is I need to tell you when I talk about the with replication. So in with replication, your categorical variable categories will be replicating, means repeating, right? Whereas in case of without replication, the categories of the categorical variable will not be repeating. Only once they will appear, right? So that way, this is known as the case of without replication. So once I'll explain you applying this using Excel. So I'll give you the examples already mentioned in your sheets, right? So that way we will understand that what is the meaning of with replication, what is the meaning of without replication. So one by one we'll go with that, right? So this is about the simple, means what is I have just discussed is very simple form of the ANOVA. Generally we are representing the ANOVA by capital letter F, right? So we will be having different hypotheses in case of with replication and without replication. When I talk about with replication, here you need to formulate 3 null hypotheses, right? Whereas in case of without replication, you need to follow or make only 2 null hypotheses, right? Why we are making these hypotheses? I think once I'll take the example, so I'll explain you these things. In case of one-way ANOVA, only one null hypothesis we need to create. Till here, I'm clear to everyone.
Yes, ma'am.
Yes, ma'am.
Fine. So now I'll start with the performing of one-way ANOVA. So I'm expecting you to open the sheet named as one-way. Everyone has opened the sheet, downloaded. Yes. Everyone is ready? So shall I start?
Yes, ma'am.
Yes. So friends, I'll explain you what the problem is given to us. Here you can see, here we are having the various tape strengths, right? Means here we are having 3 suppliers, supplier number 1, 2, and 3. So from these 3 suppliers, we are getting the tapes. So these are the strength of the tapes mentioned in this particular or in the column A, B, and C, right? So we can say Anyone who can tell me how many variables we are here? Anyone who can identify using or given this information? Yes. Anyone who can tell me using the given information how many variables we are having right now?
Ma'am, two, the
Okay.
length and the three different types of tapes.
Very good. Oh no, three different types of supplier.
Yes, suppliers, sorry.
Yes, yes, right. So here, ma'am said correctly. We are having two variables. The dV. What will be the dV?
Strength.
Yes. Strength of tape is the dV. And IV will be type of supplier. Right? And it is having three categories: supplier 1, supplier 2, and supplier 3, right? So that means if I want to perform one-way ANOVA, this basic requirement is fulfilled by the given data, right? Is it clear?
Yes, ma'am.
Right. Next comes, you need to formulate your null hypothesis. So anyone who can help me to formulate null hypothesis?
There is no difference between the strength of the tape within different groups of suppliers.
Okay. Okay. Anyone else?
The strength of the tapes remains the same, obtaining from the three suppliers.
Yes. Yes. Anyone else who wants to say something? Anyone? I think I can hear some voice. Anyone who wish to say something? Fine. So I think sir said correctly. I can say there is no significant difference in the mean tape strength
Obtaining from any of the suppliers.
obtained from three suppliers, right? Fine.
Yes, ma'am. Yes.
Yes, ma'am.
Then alternatively, I can write there is a significant difference in the mean tape strength obtained from three suppliers. This is the one way. Other way can be there is no significant impact of the type of supplier on the mean tape strength. This is also you can make, right? Or the tape strength is same received from all the three suppliers. This is also you can make, but these will be little informal, right? If you want to write exact in the terms of a statistical way, so this is the way you can write it. Is it okay?
Yes, ma'am.
Fine. So I think we are now ready to go to perform ANOVA because we have made all the things. Only need to decide upon the level of significance. So suppose we want to check it at the 5% level of significance, right? Now, so performing this, perform this, we'll go to the data, we'll go to the data analysis, and at the initial stage or at the initial or at the very upper side of this particular dialog box, you can find we are having three ANOVA listed. The very first one is ANOVA single factor. So factor meaning is independent variable. So we have understood using the given information that we are having only a single independent variable, which is the type of supply. So that means, so table test is the first one. Remaining two are based on the two-way ANOVA. That is two factor means two independent variables, right? So here we'll go with the first one, which is ANOVA single factor. Fine. So click on OK. Everyone, it is okay. May I click on OK?
Yes.
Yeah. Now it is requiring the data range. So you can select your entire data like mine. So my range is A2 to C32. I hope everyone has selected the same range. Done?
Yes.
Now, next one is data is grouped by columns or rows, right? So you can see our data is in the column form. Yes or no? And by default option is column only.
Yes, ma'am.
Fine. Is it fine, everyone?
Yes.
So you need
Yes,
to
ma'am.
be careful if your data will be in the rows. In that case, you will select the second option. But our data is in the column, so we can go with the columns because Excel can contain or store data in row form also. Up to us in what manner we have stored our data. Is it fine?
Yes, ma'am.
Right. Now click on the labels in the first row because we have selected the data including the headings or the labels of the column, which is supplier 1, supplier 2, and supplier 3. So I selected this checkbox. Alpha we decided as 5% only. So I think we are not making any changes in this. Output are the three different options available to you to get it. So I'll go with the first one. You need to decide in which cell you want to generate your output. Fine. May I click on OK?
Yes, ma'am.
Yes, ma'am.
Fine. Okay. So I think I got the output. Please confirm me whether you are getting it or not.
Yes, ma'am. Understand.
Got it?
हाँ, ma'am.
So shall I proceed to explain the output now?
Yes, ma'am.
Yeah. You can find the very first table is the summary table we are getting. There you can see that we are having the three groups, supplier 1, supplier 2, and supplier 3. In each group, we are having 30, 30, 30 count, right? Means 30 tips we have received from supplier 1, 30 from supplier 2, 30 from supplier 3, right? Sum of the tape strength is given in the next column. These are the sum of the tape strength. Next column of this is giving us the mean strength of the tapes in all the three different groups. Means whatever tapes we are procuring from supplier 1, the mean tape strength is 9.24, 9.13 from the supplier 2, and 9.84 from supplier 3. In the next column, we are getting the variance in the tape strength received from all the three suppliers. This was the summary table, right? Going down, here you can find, here we are having the ANOVA table available with us. So those who are from the statistics and if they have performed statistics manually, they know that when we are doing statistics manually for ANOVA, so the final table is we need to make like this only, right? Even manual form also we are making the same kind of table. There we are having the first column as source of variation. Source of variation meaning is between groups and within the groups. A meaning of between and within the groups I'll explain you. I mean I'll try to explain you. I hope I'll be able to explain you in the little easier manner. So if I talk about source of variation, means if variation is coming in the mean, so what are the source of those variations? So first one is the between groups. Between groups meaning is what? This. We are having total three groups: supplier 1 group, supplier 2 group, supplier 3 group. So in the different groups, whatever the difference is coming in the mean, the variance of that is known as between groups variance. Is it clear? So means due to the groups, the variance is coming. Similarly, next one is the within the group. Within the group meaning is what? If I talk about supplier 1, so supplier 1, whatever tapes we are receiving, we can get easily the mean of those tapes, right? And then we can compare whether the each observation is similar to the mean or not. So this is quite obvious, it will be different. So you can find in case of group number 1, the mean is coming as 9.24. So you can compare all these figures from 9.24. You can find there is a variation, there is a difference coming, right? So that is within the group variation. Is it clear?
Yes, ma'am.
Right. So that way, there are two sources which can cause variation in the data between the group and within the group. Further, you can find sum of square. So sum of square generally that is different. I think if those who are knowing the that standard deviation formula, that is x minus x bar square something. So that is the same thing which we are getting here. After that, degrees of freedom. In case of between groups, how many groups we are having?
3.
3. So in case of this, it is n minus 1, which is 3 minus 1. Okay, so it is 2. Fine. Clear, everyone?
Yes, ma'am.
Similarly, in case of within the groups, the degrees of freedom is n minus k, where n is total number. Here you can make n capital, so that will be easier for you to understand or differentiate. N meaning is total number of observations. So 30 plus 30 plus 30, which is 90. 90 minus k meaning number of groups, which is 3. So 90 minus 3, which is 87. So this is your degrees of freedom. Is it okay?
Yes, ma'am.
Then mean sum of square. So when you are dividing your sum of square by the degrees of freedom, you are getting mean sum of square. That is 8.84956 divided by 2 will give you this value. Similarly, 29.1887 divided by 87 will give you this value. Is it clear?
Ha, ma'am. Clear.
Finally, the F value. F value is coming by dividing the between groups mean sum of square divided by within the group mean sum of square. That is 4.42478 divided by 0.335 will give you this F value. Is it clear? If you want to perform or want to check, you can check also. Because manually when we are doing these ANOVA, so this is the way we are getting all these things. Done?
Yes, ma'am.
Check like this divided by this. You can check. Fine. Clear?
Ha, clear.
This divided by this. Done? We got it?
Yes, ma'am.
Now the p value and the critical value, this is the table value, standard value of the F, and this is the probability value or the significant value, right? So now you need to compare your this p value from the level of significance, or you can compare the F calculated value and F critical value. So anyone who can help me to make decision here? Yes. Anyone? Yes. Anyone? Why you people are so quiet? Yes. Yes.
Since p value is more than the critical value as per the table, we can say that null hypothesis is rejected.
Yes. On the basis of which value you have said, sir?
Since p value is more than the critical value.
P value means this.
Yes.
I think we are not comparing p value with critical value. P
Oh,
value is compared by the level of significance.
then, then,
Then anyone? It is not like sir, you attempt if p value is given, I said you need to compare this by the level of significance. So level of significance is clear. It will be 5%, right?
Huh.
So what will we do? Anyone? I think, I don't know who was attempting. Neeraj sir,
Ma'am, me.
Saib sir. Fine. Anyone else who wants to try? Yes. Why you people are so quiet? I don't know. Are you listening to me or not? Only one or two people are interacting today. What happened? Where is Viswas ma'am? Ma'am has not joined today. Anyone else? First thing is this, you can use either this also, F critical and calculated. So F calculated is greater than F critical. Yes or no?
Yes.
If it is the case, what we do? If this is the case, what we do?
Reject the null hypothesis.
We reject H0. Correct. Now comes p value. P value is less than 0.05. That means again we need to reject the null hypothesis. So it is 9.9 e minus 0.6 means 10 to the power minus 6. Okay? Clear
Yes,
everyone?
ma'am.
Which is
Yes,
a
ma'am.
very small value. So that is why we can say in comparison to the 5%, this value or this figure is very small. That means we need to reject the null hypothesis. And if we are rejecting the null hypothesis, what we can conclude? We can conclude that there is a significant difference in the mean tape strength obtained from 3 suppliers. Is it clear?
Yes, ma'am. Clear.
Right. Now, if mean tape strength is differing when we are considering the type of supplier, you can check here. This is 9.24, this is 9.13, this is 9.84. So which tape strength is good here? Anyone?
Third supplier, so supplier 3.
Third supplier. Very correct. Very good. Thank you, ma'am. So we can say we have received the tape, we have received whatever is the tapes we are receiving from the supplier 3, the strength of that supplier or that the strength of those tapes received from the supplier 3 are good in terms of strength, right? So that means we need to target or we need to ask or we need to get more tapes from supplier number 3. Is it clear?
Yes, ma'am.
Yes. So this is what you can do using Excel. But if you are using some other softwares like SPSS or maybe Stata, MATLAB, R, Python, etc., other softwares if you are using, so those software are providing you to perform something else along with ANOVA, right? And what that is that if you are rejecting the null hypothesis of ANOVA, further you can make pairwise comparison, because what ANOVA does for us, ANOVA can compare all groups together. Means it is saying that all the three groups mean if it is considering, so in these three different groups the mean is differing, but it is not telling. Means suppose there are three groups, so what combination it will be? Supplier 1, supplier 2, second one is 2 and 3, and then next one is,
One and
these are the three combinations of pairs, right? Means if I want to compare the tape strength of supplier 1 and supplier 2, who is better? Similarly, 2 and 3, who is better in these two? Similarly, 3 and 1, who is better in these three? Means whether the mean is significantly differing in these different pairs or not, that cannot be done by ANOVA. ANOVA can simultaneously tell you that at least one mean is differing, right? When you are making your hypothesis in the word form, generally you are writing at least one mean is differing. One mean, any one. even then ANOVA will tell you there is a significant difference. Means suppose in first two, if you want to see, you can see there is a very less difference in the mean value. Yes or no? 0.11 only the difference. Yes.
Yes. Yes.
Whereas in comparison to these two, if I talk about 9.84, there is a little large difference. So whether first group and second group mean is significantly differing or not, that cannot be commented using ANOVA. So if you want to do the pairwise comparison, you need to use other software. ANOVA can means Excel can only give you the results of ANOVA. Is it okay?
Yes, ma'am.
What about others? I hope it was not much
Yes,
technical.
ma'am.
Clear?
Yes, ma'am.
Fine. Now, moving ahead, talking about the next sheet, which is the practice sheet of one-way ANOVA. So I think you people can use this sheet for your purpose. Now open the next sheet named as with replication. Once you have opened it, tell me so that we can proceed. Fine. Shall I proceed? Yes. Please say something, friends. Have you opened
Yes,
it?
ma'am. We can proceed.
Yeah, fine. Thank you, sir. Now you can see in the with replication example, here we are having the almost similar data which we have got there, but one more column is added here, which is the box type. So when I talk about two-way ANOVA, we will be having one dependent and two independent variable, right? I think I have not written here, right? So you can write this thing. When you talk about two-way ANOVA is having 1 dB and 2 IVs with categories. Clear, everyone?
Yes, ma'am.
Done. So coming to the with replication sheet back, I can see here, or I can tell you that we are having the tape supplier 1, 2, and 3. We are having the box type 1 and type 2. Only these two type of boxes given, and this is the tape strength given. So that way you can find we are having three variables. First one is type of supplier, then type of box, and then tape strength. Is it okay? Friends, clear?
Yes, ma'am.
Fine. Now you need to formulate your hypothesis. So I hope in your sheet I have written or not. Go down and check hypotheses are there or not.
Not given, ma'am.
Right. So we are going to formulate the hypothesis. Before formulating the hypothesis, I need to make you clear the concept of with replication, right? So you need to check here the variable which we are taking in the row. So here we are having the box type in the row. And there you can find type 1 is repeating sometimes. Type 1, type 1, type 1, type 1, type 1, right? Similarly, you can go down after type 1, there is type 2, and it is again repeated or replicated. That way, this is the case of replication, right? Means we will be having replication of the categories of the categorical variables. So the categories are repeating. So type 1 is a one category, type 2 is a second category. So type 1 is repeated some number of time. Similarly, type 2 is repeated for some number of time. That is a replication case. And obviously, if type 1 is repeated, that means type 1 supplier, tape supplier 1. So for tape supplier 1, from the type 1 box, we are taking the strength of the tapes. So whatever number of times type 1 is coming, so at each time we will pick one of the tape from the type 1 box, and then we will make or measure its strength. So that way, this is the meaning of the replication case. Is it clear? Replication case is clear to everyone? Yes. Everyone, please say something. Meaning of replication is clear.
Yes, ma'am.
Fine. Now we will formulate the hypothesis. So, as I said, when we talk about the replication, we need to formulate how many number of hypotheses? Yes, I just said initially when I was talking about the concept of ANOVA, how many hypotheses we need to make? Yes. Why people are so quiet today? What happened? Is it okay? Fine, everyone? Shall I proceed?
Yes.
Anyone who can tell me the hypothesis? How many I need to make? Yes. I think I said we need to make total 3 hypotheses. So the first hypothesis will be the combination of your dependent variable and first independent variable. Second will be the dependent variable and the second independent variable. Third will be the dependent variable and both the independent variables. Is it okay? Clear to everyone? I said we need to make total 3 hypotheses. Yes or no?
Yes.
Yes. Now we will write them in the word form, right? If I'm talking about this, I'll say my null hypothesis in this case will be there is no significant difference in the mean tape strength due to type of box. Is it clear?
Yes, ma'am.
Fine. So if this is my first hypothesis, anyone who can help me to make my second hypothesis? Yes. What will be the third next hypothesis?
Due to type of supply,
So can you tell me in the word form?
there is no significant difference in the mean tape strength due to type of supply.
Very good, sir. Fine. And what will be the way of making third hypothesis? Third will be there is no significant difference in the mean tape strength due to the
Type of box and supplies.
due to the interaction effect of type of suppliers and type of box. Fine. Clear? Clear to everyone?
Yes.
Fine. So we have made all the 3 hypotheses here. Now, for every hypothesis, you can make your alternative hypothesis and then you can check it. So I hope it is fine. May I start processing with the testing of these hypotheses? Everyone has written, I hope, right? I don't know how many of you are writing. If writing it is good, shall I proceed?
Yes, ma'am.
Fine. Okay. So go to the data analysis and click on ANOVA two-factor with replication. So replication is there in our case. Categories are replicating. So we will go with this and click on OK. Now here you need to firstly see what this particular dialog box is asking you to supply. First one is the input range of your data. I think that you can give. Next thing is very important to see here, which is it is asking you rows per sample, right? Rows per sample meaning is what? Means the variable which you have taken in the row, in that for a particular category, how many rows you have captured, right? So I think we have not done that. We have not counted that. So I'm canceling this box, canceling this also, and then I'm coming back here. Now you need to see I'm selecting the type 1. How many times the type 1 is written here? So you can see all the type 1 I selected and the count is coming as 15. Visible? I'm rotating my mouse. Similarly, in
Yes.
your sheet also you can select if you are performing. You can see count is coming as 15, right? Now I'm selecting the second category and I'm checking. Again, you can see the count is coming as 15. Fine?
Yes, ma'am.
Right. So this is the thing you need to keep in your mind, that every category of the variable which you are taking in the row should be coming same number of times, because I think you have already seen rows per sample. So that means there is only one box. So that is why you can only enter one value there. So that is the thing. That means you need to take same number of time the repetition of each category. Is it okay? Clear to everyone? Friends, okay, fine.
Yes, ma'am.
So click again, go to the data tab and select the data analysis tool pack. Select the ANOVA two-factor with replication. I hope everyone is with me till here. May I click on OK?
Yes.
Fine. Now give the range of your data. So select the entire table. So my range is coming as A2 to D32. A2 D32. This is the range. I hope everyone is having the same range, those who are performing along with me. Done?
Yes, ma'am.
Fine. Now rows per sample, we have just taken the count. It is 1, 5, 15. So you can enter 15. Fine. Done. So, shall I proceed further?
Yes, ma'am.
Level of significance is 0.05, right? Which is 5%. So I think we are not making any change here. I only need to give the output option where I want to get the output. So I'm selecting a blank cell. Oh, I made a mistake. I need to come here. I need to select a blank cell. Right. I did. Fine, everyone. May I click on OK?
Yes, ma'am.
Okay. So click on OK. I hope everyone has received the output. Once you are done, please tell me so that we can interpret the results. Done, everyone?
Done.
Fine. So you can see the first table, which is the summary table. And the summary table first section is talking about when you are considering type 1, means box type 1, right? In case of box type 1, you can see we are having 15, 15, 15 observations. Means you can find here 15 from supplier 1, 15 from supplier 2, 15 from supplier 3. Right? So this is the sum of this tape of strength received from supplier 1, 2, and 3. Likewise, the average, that is the mean tape strength from supplier 1, 2, and 3, and the variance in the tape strength received from supplier 1, 2, and 3. Next, type 2 box. So again, count will be similar. This is the sum, average, and the variance in the strength or the tape strength received from the different suppliers. Going down, this is the combine, means when you are combining all three. So that way we are having total 30, 30, 30 observations. Sum, average, and variance of the tape strength is mentioned here. Is it okay? Fine, everyone? Shall I proceed with the final table? Friends, say something. It's like I'm not getting clarity that are you people listening to me or not. Shall I?
Yes.
Yes,
Fine.
ma'am.
Fine. Now you can see we have, sorry, anything? Fine. So here, this is the final ANOVA table. There you can find source of variation, sample meaning row, column means the second variable which is there in a column, and third one is when these two variables are interacting, and last one is within meaning is the error, right? Now, sum of square, degrees of freedom means sum of square, F, p value, and critical value. We have already discussed these things, right? So finally, if I talk about sample meaning row, and in row we have taken box variable, right? In the column, we are having supplier type, box type, and supplier type. Is it clear? So once you are looking at the p value, can anyone help me? As we have made 3 hypotheses, so you can find we are having 3 p values. So according to these 3 p values, what I need to do? Which hypothesis I need to accept or reject? Yes. Yes, friends. I don't know why people are so quiet. What is the problem? Please tell me so that we can discuss it. Yes. We should accept or reject the null hypothesis. Anyone? Yes. What is the problem today? Are you people in no mood to study? Yes. If I talk about the first p value 3.6 e minus 10, what I need to do? Accept or reject? Yes.
P value is yes, less than the significant level, that is 0.05. This is reject. Yeah.
Next, second case, in case of columns, supplier 1.
This is
Sorry,
also
Reject.
reject. In case of third,
this is also reject.
very good. Thank you so much. This is what I am expecting. Thank you for interacting. So in all 3 cases, we are rejecting the null hypothesis, right? So in that case, if you're rejecting the null hypothesis, you can conclude that there is a significant difference in the mean tape strength due to the type of box. Means when you are changing the box, mean tape strength varies or it changes, right? Similarly, there is a significant difference in the mean tape strength due to the type of supplies. Means once you are receiving the tape from the different suppliers, the tape strength is varying or it is changing. Last case is when you are considering that you are taking the tape box, suppose type box from a particular supplier. In that case also, there is a difference coming in the mean tape strength, right? That means when you are making a combination that from this supplier you are taking this kind of box, so the tape strength will be differing. So you need to see this thing that in all the three cases, whether it is a single variable, single meaning is what? This is known as main effect, right? Similarly, this is also known as main effect. The last one is known as interaction effect. Interaction effect means both the independent variable will be considered, right? And combinedly, they are telling you whether they are making any impact on the dependent variable or not. So that means once you are considering the type of box and the type of supplier, in both the cases, the mean tape strength varies, right? Is it clear?
Yes, ma'am.
So this is two-way ANOVA with replication case. Next sheet is for the practice purpose, right? You people can use this sheet for your own practice purpose. And further, we'll go to the third sheet without replication. So I hope I can start with the without replication case. Shall I start?
Yes,
Yes.
ma'am.
So here you need to read the problem given. Here you need to read the problem given. So I'm expecting you to read. I'll give you 2 minutes. Read it and then we'll discuss how to solve it and I'll explain you without replication also after this. So please read it carefully. And please positively, I'm expecting everyone to read it. Sheet is already available with you. Yes. Reading done?
Done.
Yeah, thank you. So you can see the problem is stating here that there is a new fertilizer developed by a particular firm to increase the yield of crop, right? So this was applied on 4 different types of crop: wheat, corn, soya, and rice, right? And there 3 different blends were prepared: blend X, Y, and Z. So these were applied on a different crops, and that way it was seeing that what is the yield of crop once you are applying these different blends on the different types of crop. So you can see in the table we are having 2 independent variable, that is type of blend and type of crop. And in the combination of these two, we are having the crop, yield of crop, right? That is production of crop. So that way you can check. We are having the 3 variables: dependent, that is yield of crop, numeric variable it is, and we are having the independent variable, that is type of crop and the type of blend. So these 2 are the categorical variables, right? Now you need to see when I talk about the without replication. So you can check here the variable which we are taking here in a row, it is not replicating. There are 3 categories of type of blend or means or type mix, fertilizer mixture, right? You can find blend X, Y, and Z. So X means we are not replicating blend X some number of times. Similarly, Y and Z. That means it is a case of without replication. Here you are not replicating the categories of your dependent variables. This will be the without replication, right? So now in case of without replication, I think I told you we need to formulate two hypotheses. Anyone who can recall? So maybe I said initially at the starting of the session when I was discussing the concept, I said in case of without replication, you need to make only two null hypotheses, right? So here you can see, I think in my sheet it is already written. If you want, I will read and written for you. So if I talk about the first one, I say, anyone who can tell me what will be the hypothesis here? Anyone? Yes. Anyone who can tell me?
There is no significant difference in blend X and out.
I'm not getting. Sir, are you talking to me?
Yes.
Sir, not clear. Will you please repeat?
There is no significant difference between blend and output per yield
There is no significant difference.
between particular blend and output.
Done.
And type of blend.
Second one could be type of blend. Blend.
Done.
Yes.
Yes. So these will be the two null hypothesis. Means once you're considering the type of blend, once you're considering the type of crop. So whether the different type of crop is causing a different yield of crop or not, or whether the different blend which you are using is causing the difference in the yield of crop or not. So this is what you need to check. Done. So suppose we want to check this at 5% level of significance, right? Now, to perform this, we'll go to the data analysis and we'll select the third ANOVA two-factor without replication. Done? Sorry?
Yes,
Is
ma'am.
it fine? Yeah. Click on OK. Fine. Now provide the data to the Excel. So I selected the range. My range is B5 to F8. B2 BF BF F8. It is okay. Sorry, B5 F8. It is okay.
Yes, ma'am.
Fine. Now I selected the data including the labels. So I'm checking the labels box. Alpha is by default 5%. Now output I'll generate in the same sheet. Done.
Yes, ma'am.
Click on OK to get the output. I hope everyone has received the output. Shall I start? Anything you want me to repeat? Everyone has got it. Friends say yes or no. Shall I proceed?
Yes.
Yes. So first is the summary table. Here you can check, or here you can see we are having the first section in the form of blend. So here we can see we are having 3 blends X, Y, and Z, and per blend we are having count 4. So you can check blend X, count 1, 2, 3, and 4. Means 4 yields are given in context to the blend X, right? So this is the sum of yield of crop for blend X, sum of yield of crop for blend Y, and sum of yield of crop for blend Z. Similarly, average yield of crop and the variance in the yield of crop for blend X, similarly for Y and Z is mentioned in the first section of the summary table. Going down, Now we are having the data in context to the wheat. Oh, sorry, in context to the crops. So there you can find, if I talk about the wheat, so there are three different yields of wheat, right? So that way per crop, we are having 3 observations, right? Now this is the mean yield of, this is the sum of yield of crop for various different crops, then average yield of crop and the variance in the yield of crop for the various categories of the crops. This is the summary table. Is it clear? Yes, friends.
Yes, ma'am.
Fine. Going down, talking about the ANOVA table. So in ANOVA table, you can find here, it will always be same like the previous two. We are having the source of variation, sum of square, degrees of freedom, mean sum of square, F value, P value, and the critical value, right? Now, talking about the rows. Rows is indicating what? Rows is indicating the blend, column is indicating the crop, right? So that is why I have written here blend and crop. Now you can see directly the F value and sorry, the P value, which is this. So you can check the P value for rows and columns both. Anyone who can tell me what we need to do here?
The p value is less than the significant level, usually 0.05. So, hypothesis is rejected.
In both the cases, sir?
No, first,
No, first. Second
In
is
first.
accepted.
Yes, very correct. Thank you. So in case of number 1, in case of rows, that is in case of blend, we are rejecting the null hypothesis. In case of crop, we are accepting the null hypothesis. So we'll come to our hypothesis. This is what we are accepting. Crop 1 we are accepting, right? So that way we can say there is no significant difference in the mean yield of crop due to the type of crop. Means once you are talking about the various kinds of crop, it is not making any difference in the yield of crop, right? This type of crop is not impacting the yield of crop. This is the what I can say finding. Second one is this hypothesis we are rejecting. So we will conclude there is a significant difference in mean yield of crop due to the type of blend. Means once you are changing the different blends, it is making impact on the yield of crop. Is it clear?
Yes, ma'am.
So this way, this was the without replication case of ANOVA. Next sheet is the practice purpose sheet for you. So before ending the session, I want to conclude, and in terms of research, because I think this is the problems which I have already given to you to perform and to understand how you can perform ANOVA and two-way ANOVA. Usually when I talk about the research, in research generally we are not talking about the without replication case. Or maybe if you are talking about the without replication case, that will be the case where we are doing the experimental studies. So means experimental studies are like this, where you are experimenting the thing, right? Generally in agriculture, medical field, psychology, etc., we are doing this kind of experimental studies. There, the two-way ANOVA without application is applicable for us. But as I belong to the management field, if I'm not doing any kind of what I can say experiment or something, I don't want to do or I don't want to see the changes in any particular thing. So that way, I think I can go. I do not need to apply the without replication. It is totally depending upon which kind of study you are carrying on. Accordingly, you need to decide whether the with replication will be applicable or without replication will be applicable. Although looking at the type of data or looking at the presentation of data, you can easily understand if your data is coming without a repetition of the categories, that means you can perform without replication case. But if these are repeating for some number of time, in that case with replication will be applicable in your case, right? So now if I want to summarize the whole session today, what I had discussed. So we started with the concept of ANOVA. As I said to you, ANOVA is a kind of parametric test, right? So as it is a parametric test, so that means you need to check the normality assumption, you need to check the homogeneity of variances. So these all things you need to do firstly before performing the ANOVA, right? If assumptions are meeting by your data, it is fine. You can go ahead and perform ANOVA. If these are not meeting, you can go for performing the Kruskal Wallis test, right? So that you can perform. After that, tried to explain you what is ANOVA. So we understood this thing. ANOVA is nothing. It is again a kind of statistical test which can help us to see the significant mean difference, right? If the significant mean difference we need to see, we can go for ANOVA. Further question comes, why ANOVA when we are having the t-test? So I think that also we discussed that t-test can only compare the mean of two groups. If you want to compare the mean of more than two groups, in that case you need to go for the ANOVA, right? So t-test is applicable in case of only when you want to compare the mean of more than two groups. Sorry, in case of two in case of the comparison of the mean of two groups, you will go for the t-test. In case of performing or comparing the mean of more than two groups, you will go for the ANOVA, right? Then I tried to explain you the types of ANOVA, that is one way and two way. And we understood what is one way. So one way is requiring one dependent, one independent variable with the various categories, more than two categories, right? So after that, we have seen two-way ANOVA. Two-way ANOVA is again requiring the variables, but this time we need to have three variables, one numeric and two categorical variables. In categorical variables, you can have the several categories, right? Once you're talking about performing of two-way ANOVA, you need to decide upon whether it is a without replication case or with replication case. Usually, in case of with replication, you can easily understand that when the particular categories are repeating of your categorical variable, in that case, it is quite clear that you will go for the with replication case, right? So in with replication case, you need to make total three hypotheses, two for the main effect, right, and one for the interaction effect. Two for the main effect meaning is you need to see simply whether your one independent variable is making any impact on your dependent variable or not. Similarly, your second variable is making any impact on your dependent variable or not. So that way, we will make total two hypotheses for the main effect. Third hypothesis will be of the interaction effect. Interaction effect meaning is what? You need to see once you are combining both the independent variable, means once you are considering both the independent variable, in that case, these two combinedly making an impact in your on your dependent variable or no, right? So that will be the third hypothesis. Lastly, I explained you the ANOVA, two-way ANOVA without replication case. So without replication case, I said to you that it is generally a case, generally once you're doing or carrying on the experimental studies. In that case, you are generally performing without replication case. There we have understood that we need to have again three variables, two independent and one dependent. And generally, there will be no replication of the categories of the independent variable. So that is why it is known as the without replication case. And in this case, you need to make total two hypotheses. Both will be means two null hypotheses, I need to say. So one will be for the one independent variable and dependent variable. Second will be of the second independent variable and dependent variable. And then using the data analysis tool pack, you can easily apply because there is clearly mentioned ANOVA with replication, without replication, and with replication without replication, which means that particular option you need to opt, and that way you can perform. So this is about the ANOVA from my side for the day. Now the platform is open for questions and answers. So if you are having any questions, you please ask. Yes, I'm waiting for your questions. Yes, you are having any questions regarding what we discussed today? Yes. Any question, friends? I hope you people are listening to me. Yes or no?
Yes, yes.
Great. No questions? Friends, I hope you are listening. Again, I'm repeating. No questions?
No, ma'am.
We are listening, but we don't have questions.
Fine. Thank you. Someone has raised hand. I don't know who. I think anyone who wants to ask something. No. So can we call off the meeting for the day? Tomorrow is the last day of the FDP. Tomorrow I'm going to discuss the correlation regression and some of the situations I'll provide you. Means I'll show you some of the situations where I want your intervention, that you need to tell me in that particular condition which test is suitable to apply. Right? So that we will discuss after completing of correlation and regression. Done, everyone?
Thank you.
Thank you.
Thank you.
Thank you.
Thank you, everyone. So, Yoga sir, are you there? Sir, we are done for the day. Thank you. Haji sir. Tomorrow is the last session. I think I said this. We are meeting means for the last session tomorrow. Thank you. Thank you, everyone. Good night. Take care.
Thank you and good night.